Hello Math 112 students. Just continuing on with Chapter 3, a homework assignment. So we are on problem 32 now. We're moving to solving kind of a different kind of equation. This is an equation, these are equations involving radicals and also involving rational exponents, which is very much related to radicals, as we'll see in a minute. But let's just get on to this problem here and how we can go about solving it the best way. When we have a radical like this in the problem, what you want to do is isolate that radical. In other words, get that radical term by itself on one side of the equation. So I'm going to move this plus 7 over by subtracting 7 from both sides. And that's going to give me the square root of x equals x minus 6. And at this point, once I get the radical term by itself, I can then get rid of that radical. And I'm going to do that by doing the inverse of that radical. So, for instance, a radical and an exponent are inverses of one another. And you have something here, a little number right here, it's called the index of the radical. And that is the number that is going to be the same number as the exponent that you're going to use, which is going to serve as the inverse of that radical operator. So if I want to get rid of the nth root of something, then I'm going to use the nth power or nth exponent of that thing, and that's going to cancel. Now when it's a radical with nothing there, when there's nothing in the inside the little check mark here to serve as the index, it's an invisible 2. It's understood to be a square root. It's an understood 2 there. So if you want to get rid of a square root, you use a squared exponent. And that gets rid of that understood squared index of that radical. So to get rid of this is a square root of x. To get rid of it, I am going to square it. And I do the same thing. As long as I do the same thing to both sides, I'm good. So getting rid of that radical, I've got now x equals, and I'm going to square x minus 6, which means I've got to do x minus 6 times x minus 6. And FOIL it out. So that gives me x squared minus 12x plus 36. Once all of that is distributed and combined like terms. Then at this point, I'm going to now move my x over to combine it with its like term on the other side. So 0 equals x squared minus 13x plus 36. And now I am thinking this is a quadratic equation that I can solve with maybe factoring or certainly the quadratic formula. I believe I can factor this one. If I can factor it, that's usually what I like to do because it's quick and simple. So what multiplies to get 36 and adds to get negative 13, negative 9, and the negative 4. That means x equals 9 and 4. Alright. There is one thing that I need to tell you to look out for, and that is when you are solving these radical equations, and to get rid of these radicals, you have to raise these things to higher powers. That can increase the number of solutions. And when you increase the number of solutions, you sometimes get extra solutions that aren't true solutions to the original problem. They're called extraneous solutions. Like extra unneeded things. So what we need to do to check that is take our solutions and plug them back into the original problem. So I'm going to do that. The square root of 9 plus 7 equals 9 plus 1. That's 3 plus 7 equals 10. So that checks out. 9 is a good solution. Let's try the other one. The square root of 4 plus 7 equals 4 plus 1. So that gives me 2 plus 7 equals 5. So that's 9 equals 5. That does not check out. So 4 is one of those extraneous solutions. So that 9 is the only true solution. That's going to happen sometimes. It won't happen every time. Sometimes all the solutions you get will work. But a lot of times you get solutions to these kinds of equations that aren't true solutions. You got to check it. All right, I want to also show you how you could do a problem like this. This is the same problem as before, but I closed out and went back in, so now it's got different. It's a little different numbers here. But how you could do this using your calculator. So this gives you a plan B. If you get stuck doing it by hand, you can do it with the calculator. So let's talk about how to do that. What we're going to do is we're going to put the left side into y1 and the right side of the equation into y2 and find where they cross. So let me show you that. Alright, so I'm going to put the left side, that was the square root of 2x. Didn't work out. The square root of 2x plus what? Plus 6. Plus 6. And the other one was x plus 2. Then you hit graph. We hit graph. And we can kind of see up here where it crosses. That it's going to cross right here. So we can hit second calc. Option 5 is intersect. Then it says first curve. So the calculator's thinking to itself, there might be a lot of things graphed here. And I want the person to tell me which curves do you want me to find the intersection of. So since we only have 2, it doesn't matter which one's the first curve or the second curve. So I can just let this blue one be the first curve. I hit enter, and then this red one that's already on the red one, I can let that be the second curve. Then when it says guess, you can take this blinky thing, this cursor, near where it crosses. And I'll go ahead and tell you this. If it crosses more than once, whichever intersection you have this cursor closer to when you hit guess is the one it's going to give you. So I'm going to hit enter, and it tells me that the intersection is x equals 8, y equals 10. So that's the solution. If we're just solving for x, the answer is x equals 8. The 10 would just tell you what you would get on both sides of the equation. 10 equals 10 if you plugged in 8 for x. Alright, the next equation is what's called a rational exponent equation. But this is also pretty much like a radical equation, because a rational exponent is a radical. Let me just remind us of that in case we don't remember. If you have a radical with an index of n, let's just say it was x, that is the same thing as x to the 1 over n. So the index of the radical can be written as part of the exponent if you write that index in the denominator of the exponent. Let's say we had the nth root of x to the m. Then we could just rewrite that as x to the m over n, and that's the same exact thing. So let me show you just a couple of ways to do this problem. Alright, we could use what we just said. We could rewrite it. X to the 2/5 is the same thing as the 5th root of x squared equals 2. And then we get rid of the 5 and the 2 separately. We can get rid of the 5th root by raising both sides to the 5th power. That gives me x squared equal to the 5th. That's 2 times 2 times 2 times 2 times 2. That is 32. Then we take the square root of both sides to get rid of that squared exponent. And that gives me x equals, remember we got to put plus or minus. Square root of 32, I can break that down to 16 and 2, and then 16 has a perfect square root, is 4, so I bring the 4 out, and the 2 just has to stay underneath the radical, so plus or minus 4 root 2. That's one way to go about it. Another way to go about it is to say x to the 2/5 equals 2. And this is a very quick and simple way to do it. If we want that 2/5 exponent to just become a 1. So a quick way to do that is to raise it to the reciprocal of that. So I'm going to raise it to the 5/2. Why does that work? That works because if you have a power to a power, you multiply those powers. So x to the 2/5 to the 5/2, you would do 2/5 times 5/2, and 2/5 times 5/2, the 2's cancel and the 5's cancel, it just gives you 1. So it's just going to give you x to the first, or just x. I do the same thing to the other side that I did to this side, so I raise it to the 5/2 also. So that gives me x equals 2 to the 5/2, and I just got to think about what 2 to the 5/2 is. Okay, and if you just remember that this means the square root of 2 to the 5th, then it's the square root of 32, and you break it down like we did before, 4 root 2. But you do have to keep in mind and remember that if you raise the other side to a power that has an even number on the bottom, that's just the same thing as taking an even numbered radical of that side. And anytime you take an even numbered radical, you got to put plus or minus. So if you can remember that, you can use this method. We can also, if you kind of want to just use technology to help you to do that part, we can just say 2 to the 5/2, and it'll tell us, it won't tell us 4 root 2, but it does give us the decimal approximation of it. So if a decimal approximation is acceptable for the answer in Math Excel, you can do it that way. Just to show you, 4 times the square root of 2 is the same exact answer. So going back, let's see what it says. Notice that it says simplify your answer, blah blah blah. It says type an exact answer using radicals as needed. That means that it will not accept gosh, what is going on with my screen? It will not accept an answer like that. So you have to know what's going on with the radical and breaking it down and all that kind of stuff as shown here. Alright, similar way to do this problem. I'm just going to go ahead and do the simple way to do it. To get rid of the negative 2/3 power, I raise it to the reciprocal of negative 2/3, which is negative 3/2. And just keep in mind, when we multiply these two together, we're going to get 1. So that cancels out, becomes 1. I also have to raise this side to the negative 3/2 power. So x equals 16 to the negative 3/2. And then we got to use radicals instead of a decimal. So just got to think about what this means. This means, first of all, what does the negative mean? Okay, what does this negative sign do? If you have a negative exponent, that flips the base. Okay, let's remember that. Negative exponents flip the base. So 16 becomes 1 over 16. And then the negative 3/2 power becomes a positive 3/2 power. And then that then becomes, let me get down here, becomes 1 over the square root of 16 to the 3rd. And then I can say, well, the square root of 16, that's 1 over 4 to the 3rd, because the square root of 16 is 4. I can do that part, that's 4, and then raise it to the 3rd power. And 4 to the 3rd power is 4 times 4, 16 times another 4 is 64. 1 over 64. So x equals 1 over 64. And now, you tell me, is this completely right? Or is there something else I need to think about? There is something else I need to think about, and it is the fact that when I'm raising this thing to a rational exponent, if there's an even number on the bottom, that is the same thing as raising it to, that is the same thing as taking an even numbered root or an even index radical. And when that's the case, remember, you got to put plus or minus. If this was an odd number, if this was an odd number on the bottom, then it would be taking an odd index radical. Then it doesn't have to be plus or minus in that case. But plus or minus 1 over 64 should be our answer here. Okay, similar situation on this problem. T to the negative 3/2 equals 27. I will simply get rid of that by raising it to the negative 2/3 on both sides. And I get T equals 1 over 27 to the 2/3, right? That's what the negative exponent does, which is the same thing as 1 over the cube root of 27 squared, which is this, what's the cube root of 27? It is 3. So it's the same thing as 1 over 3 squared, which is the same thing as 1 over 9. Now let me ask you, do I need to put plus or minus in front of the 1 over 9? The answer is no, because I raised it to a rational exponent that has an odd number in the denominator, and the denominator is the index of the radical. It's an odd index. You do not have to plus or minus it, because it's not plus or minus in that case. It's only when even numbered radical, an even index radical, that it could be both positive or negative. So this, it should be the answer. Looking now at a word problem. Daily cost of baking X loaves of bread at Juanita's Bakery is given by this function. So we have a cost function. Bread sells for 90 cents a loaf. How many loaves must Juanita sell to make a profit? All right, profit. What is profit? Profit is revenue. That means how much money we bring in, how much money we make, minus the cost. So what is my revenue? My revenue, well, I sell bread for 90 cents a loaf. By the way, X is how many loaves. So my revenue is 90 cents for every loaf that I sell. So then it's 0.9 times X, 0.9 times the number of loaves that are sold. And the cost is given by this function up here. 0.5x plus the square root of 8x plus 5,000. All right, now we could solve this by hand. It wouldn't be too hard to do. What you would do, what's it want to know? It wants to know how many loaves must you sell to make any profit at all. So that would be like the break-even point. At what point does her revenue finally equal cost? So that means we want profit to be 0 in order to find that break-even point. How many loaves in order to finally start making a profit? So we set it equal to 0. What I would do to solve it by hand is I would combine these like terms. Then I would move it over to isolate the square root. And then I would get rid of the square root by squaring both sides and continuing on with my algebra. But I'm going to show you also how you could just do it in your calculator as well. And I think this would be a good opportunity to show some things in the calculator that we haven't seen before. So what I'm going to do is I'm going to graph the cost. I'm going to graph this cost function. And I'm going to graph the revenue function, this. And I'm going to find where they intersect. In other words, where does revenue equal cost? And that'll tell me my break-even point. So I'm going to turn on my calculator. And on Y1, I'm going to type in revenue, that's 0.9x. And on Y2, I'm going to type in the cost. That was 0.5x. Let's see if I can remember here. Oh, let me show you one thing. I should have put parentheses around this to say that I'm subtracting that whole thing. If I were going to solve by hand, that's an important step, because I have to subtract the whole cost function, not just the first term. So that needed parentheses there. But let's see, let's type it in the calculator. 0.5x plus the square root of 8x plus 5,000 plus the square root of 8x plus 5,000. And I hit graph. As long as this little circle up here was turning, it means it's still graphing it. But notice I can see a blue line, so one of the things fit on my standard window, but the other curve did not fit on this window. So I'm going to adjust my window to perhaps be able to see more of what I want to see. So hit window. Alright, now put thought into what you want to see in the window by thinking about what the problem is about. What is X representing here? It's representing the number of loaves of bread that are sold. So obviously don't want to see anything less than 0, right? There's not going to be a negative amount of bread sold. So I think I can start my X min at 0. The X max, I'm thinking how many loaves might it take to make a profit? I'm just going to put in 100 and see how that does. So sometimes you kind of trial and error, keep seeing what you see when you increase your window until you finally see it. But I'm going to try 100 and see if that gets what I want to see in the window. My X scale, the X scale does not matter. The X scale is just what the dashes on the graph count by. You don't even have to mess with that. If you want to mess with it, you can. I'm going to put it at 10. If I left it at 1, that means it'd be 100 dashes. But again, that really doesn't matter. The Y min, what is Y representing here? Y is representing the money that it costs or the money that is brought in. So I'm not going to bring in a negative amount of money. So I can let that start at 0. And I'm thinking, what might the revenue and cost be? I really am not sure. I'm going to try 500 and just see what happens. I'm going to let that be, let's just say make it 100. The Y scale doesn't matter either. If you don't even change that, it won't make a difference. All right, let me hit graph. There's the blue line. And now we see another line showing up, a red line. But I don't see them crossing. But it does appear that they're going to cross. You can kind of see the red curve going here and the blue curve going here. And the blue curve looks like it's catching up with the red curve. It's going in a steeper angle, so it's going to cross it, it appears, later down the line. So let me adjust my window again. I want to see further to the right. So let me let my X max, instead of being 100, let me let it be, let's try 400 and see if that gets it in there. Alright, it does. So I just adjusted my window one way and I saw more, but it didn't let me see enough of what I wanted to see, so I adjusted it even more to let me see however far I wanted to see or needed to see to get a good picture of what's going on with these two curves. Now I can find the intersection. Second calc, intersect is option 5. Alright, it's going to say first curve, second curve. So first curve, it doesn't matter. I'm just going to hit enter. Second curve, I'm just going to hit enter again. Then it says guess, and I would want to take this cursor kind of near where they cross, but it doesn't really matter how close I get. I could have left it where it was. Just hit enter again. And it tells me the intersection is 203.5 and 183.2. So basically what I'm saying is if I sell around I will finally start to make a profit when I sell around 204 loaves of bread. And that's the cost and the revenue will both be about $183 at that point. Let's go back to our problem. Juanita must sell what? Well, I've already entered the answer in here. But the answer is, it says round to the nearest whole number, 204 loaves to make a profit. All right, next problem. We're talking about a sign in the shape of a right triangle, and it gives me information. So I'm just going to draw this right triangle. Okay, a generic right triangle here. It says that one leg is 28 inches longer than the other leg. So I'm going to let one leg be X and the other leg be X plus 28. It says, what is the length of the shorter leg if the perimeter is 120? So the perimeter is 120. All right. I think what I would do from here is I then say the perimeter is the distance all the way around this thing, right? So the perimeter is this, this, and then this, and then this, all added together. So that means that this unknown side here, this hypotenuse, would have to be 120 minus the other two. So minus x plus 28. So that would be 120. That's going to be 2x plus 28. And I distribute my negative. So 120 minus 2x minus 28. And then I could combine the 120 and the 28. So negative 2x plus 92. So this would be a good expression for the length of this hypotenuse here. And then, so I've got all my stuff in terms of x, and then I think where I would go from there to solve for x is the Pythagorean theorem. Pythagorean theorem would say a squared plus b squared equals c squared, where a and b are the legs and c is the hypotenuse. So x squared plus x plus 28 squared equals negative 2x plus 92 squared. Then from there I could solve it by hand, or I could even solve it in a calculator again. Do the left side in y1, the right side in y2, see if I could find where they cross. Let me just see what happens when I work on it by hand a little bit. That's going to be x squared plus, that's going to be x plus 28 times x plus 28. That's going to be x squared plus 28 and 28 is 56x plus 28 squared. Let's see what that is. 28 squared, 784 equals, it's negative 2x plus 92 times negative 2x plus 92. That's going to be 4x squared minus 92 times 2, 184x minus 184x. So that's going to be minus 368x plus 92 squared, 8464. Alright, let's combine some like terms. That's going to be 2x squared. Move it over there. Subtract it over here with the squared, and that's going to give me 2x squared over here. Then I'm going to move the 56x over here. That's going to give me a minus 424x. Let me move my 784. So that's going to be plus, that's a 0. That's an 8. That's a 6, and that's a 7. 7680. Okay, from here, the easiest thing to do from here might be to solve this in the app. That's probably the simplest thing to do. And if that's the case, I will just leave that to you to do it. Another way to do it would be to factor out of 2 and then try to factor more from there to solve it by hand. Alright, this is one, we've already been over this concept in class. Let me get where I can write on this. Alright, this right here, if f of negative x equals f of x, that is the definition, kind of the algebraic definition of being an odd function, which we talked about in class the other day. So if you, in other words, if you have the ordered pair 1, 3, then you have the ordered pair negative 1, negative 3. So if you plugged in negative 1 you would get the exact same answer as if you plugged in. Oh, that's wrong. That's wrong. Let me back up. Ooh, I said that. Exactly the opposite of what I should have said. Okay, I did closely enough at it. If f of negative x equals f of x, that's the algebraic definition, sorry, of an even function. So that means that if you plug in 1 and get 3, then if you plug in negative 1, you would also get 3. So that's what this is saying. If you plug in negative x, you get the exact same answer as when you plug positive x. And that is an even function. And remember that even functions all have a certain kind of symmetry. They're all symmetrical about the y-axis. Odd functions are like this. F of negative x equals negative f of x. So that means if you plugged in 1, 3, if you plugged in negative 1, you get negative 3. So whatever you plug in, if you plug in the opposite of that number, you get the opposite output. All right, and that has a certain symmetry. It has a symmetry about the origin, so that if you rotate it 180 degrees, it becomes the exact same picture as before you rotated it. So the answer to this one would be symmetric about the y-axis. All right, similar problem. Remember that we said in class that the shortcut you could take for polynomials is if all of the exponents of all the terms are odd exponents, then it's odd. If the exponents on all the terms are even, then it's an even function. If there's a mixture of both odd and even exponents, then it's neither odd nor even. So this one should be obvious, is odd. And so if it's odd, then it's symmetrical about the origin. So I believe choice C. Choice C is correct there. Next problem, notice that we have a mixture. We have an even exponent, another even exponent, but then we have an odd exponent with that understood exponent of 1. So that's a mixture, so it's neither even nor odd, so I believe the correct choice here would be D. It is not symmetric. All right, find the X intercepts means we're setting this equal to 0. And if we set this equal to 0, it's actually already in a very simple form. It's x minus 18 and another x minus 18, so it's kind of already factored. This equals 18, and that as a double root or a multiplicity 2. So the graph does the graph cross or touch when it's a double multiplicity or multiplicity 2? Remember, if it's an even numbered multiplicity, it touches. If it's an odd numbered multiplicity, it crosses. So this graph touches but does not cross the x-axis at the x-intercept 18. It says type an ordered pair, so I would have to type 18, 0 as my ordered pair. All right, the next several problems covered that same topic, so I skipped on ahead to number 48. Number 48 is talking about the concept of end. I gotta make this where I can write on it. The concept of end behavior. So let me talk all about end behavior. End behavior, you can know all about the end behavior of a polynomial simply by the leading coefficient. It's determined completely by the leading coefficient. And the degree. If you know those two things, then you can determine the end behavior completely. Anything else about the function matters as far as the end behavior is concerned. So let's talk about that. If you have an even degree, then that means both arms point in the same direction. So that means they both point up or they both point down. How do you tell? By the leading coefficient. A positive leading coefficient means both arms point up. A negative leading coefficient means both arms point down. And that's what the end behavior is. It's all, it doesn't care what happens in the middle of this function. It only cares about what happens at the ends. So at the far right end or the far left end. In other words, the arms of the function. An odd degree means the arms point in opposite directions. All right. Now, if you know that, and you know this last thing here, the leading coefficient. If it's positive, the right arm is up. If it's negative, the right arm is down. That tells you everything you need to know. So, a positive leading coefficient, even degree, means that the right arm is up, and since both arms point the same direction, the left arm is also up. Negative leading coefficient for an even degree means the right arm is down, and so the left arm will also be down. Positive leading coefficient for an odd degree means the right arm would point up, and the left arm would point the opposite, would point down. Right arm up, left arm down. A negative leading coefficient with an odd degree means the right arm would point down, so the left arm would need to point up. All right, so let's just kind of do a chart here. All right, degree and leading coefficient. The degree is even versus odd, positive versus negative. This is going to be like this. 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 So if you can just kind of know that, then you can answer any of these questions. Okay, so here's how the questions actually look. The question like this: as x approaches infinity, f of x or y approaches what? As x approaches negative infinity, f of x or y approaches what? So you should be able to answer that question. Like if we're looking at this situation, the even positive, then as x approaches infinity, then f of x is also, that means you look far to the right as possible. And if you look far to the right, where's the function going vertically? It's going up to positive infinity. And as x approaches negative infinity, it means you look as far to the left as possible. And if you look far to the left, where's the function going vertically? It's going to positive infinity on that side as well. All right, if we're looking at this, the negative even, we're looking at this graph. Then if we look far to the right, it means x approaches infinity. The graph vertically, the y value is going to negative infinity. And if we look far to the left on the x-axis, the function y values vertically are going down to negative infinity on that one as well. And you can kind of approach these the same way, okay? This one would be positive infinity for the first blank, negative infinity for the second blank. This one would be negative infinity for the first blank, positive infinity for the second blank. So let's look at the problem at hand here. All we care about to answer this question, all we have to look at is this. It's even and it's negative, right? Even degree negative leading coefficient. So that means it's going to point like this. So as x approaches infinity, y approaches negative infinity. And that's the answer. All right, let's look at this one as another example. What do we have here? We have, looking at this term, because that's the one with the highest exponent, we have an odd degree, and we have a negative leading coefficient. That means we're going to be, the right arm is going to point down, and the left arm is going to point up. So as x approaches infinity, that means we're looking at the left arm. And where's that left arm going vertically? Where's the y value going? It's going to positive infinity. So this would be our answer. All right. This is a similar question. Determine whether the limit is equal to infinity or negative infinity. So if we're looking at this, if as x approaches infinity, it means we're looking at this guy only. It's the only one that matters. And so we're looking, if we remember think about what that graph looks like, looking far to the right, where are we going vertically? We're going to infinity. So that limit would be infinity. Positive infinity. Another approach to these is you can think about them graphically, or you can think about them more algebraically. If you think about, if I plugged infinity in for x, what would I get? Well, infinity squared is infinity, and it doesn't matter if I subtract 3 from it or if I subtract 3 million from it, I'm still going to be infinity. So it's going to positive infinity. So you can think about it algebraically as well. Alright, this is number 58. So this is kind of putting some things together. We're making a rough sketch of a function based on what we know about how functions behave. So here this is already kind of in factored form, so I'm going to say x equals, if I were to set this equal to 0, x equals 3. And what does it do there? It touches because of the multiplicity 2. And x equals negative 2. And what does it do there? It crosses because it's multiplicity 1, so that's odd multiplicity. Alright, so we're looking for a graph that touches at 3 and crosses at negative 2. So that's something I know. Alright, what else do I know? I would think about kind of, what if I multiplied this out, right? If I were to do x minus 3 times x minus 3 times x. So you don't really have to multiply all this out, but just think about what your first term and your last term would be. You're going to have a lot of terms in the middle that won't really matter, but the first term and the last term can help us to draw a rough sketch. My first term will be, well, I'm going to multiply that x by that x, and then I'm going to get an x squared. And when I get that x squared, it's going to get multiplied by that x. It's going to get an x cubed. So my first term is going to be an x cubed. My last term is going to be determined, I'm going to have to multiply that negative 3 by that negative 3, and I'm going to get 9. And that positive 9 is going to get multiplied by 2 eventually, and it's going to become 18. So it's going to have lots of terms in the middle, but then it's going to have a plus 18 at the end. So what does that tell me? Here's what it tells me. It tells me that this is an odd degree and a positive leading coefficient. So it's going to look like that. The right arm up, left arm down. It also tells me that my y-intercept, my y-intercept is if I plug in 0 for x. So all these terms with x in them are going to go to 0, and I'm going to be left with that 18 as the y-intercept. So my y-intercept is 18. Alright, so my y-intercept is going to be way up here at 18. Just a rough sketch. So it touches it, my right arm is up. I'm going to touch it 3. I'm going to cross the y-axis at 18. And I'm going to have my left arm down, and I'm going to cross at negative 2. So I'm looking for that to be my rough sketch. Which graph kind of looks like that? Choice C. All right, what about this one? Well, I'm going to have an x-intercept looking at this at positive 1/3 if I were to solve that one. And for that one, the multiplicity 2, it means it touches at 1/3. And I'm also going to have an x-intercept at negative 1. And that's multiplicity 3, so it's going to cross at negative 1. Alright, what else is going to happen? I'm just thinking about, okay, if I have 3x minus 1 times 3x minus 1 times x plus 1 times x plus 1 times x plus 1, and I've also got a negative 2. If I distribute everything, okay? What am I going to end up with? The 3x times the 3x times the x times the x times the x times the negative 2. Let's see what that's going to be. 9x squared, 9x. But then it's going to be multiplied by that negative 2, so it's going to be negative 18x squared, negative 18x cubed, negative 18x to the fourth, negative 18x to the fifth is what my leading term is going to end up being, because that negative 2 times that 3 is negative 6, times that 3 is negative 18, and I've got these, it's an x, an x, an x, an x, an x, that's x to the fifth. Then I'm going to have lots of terms in the middle, but then what am I going to have at the end? Well, let's think about it. That's going to be positive 2, negative 2, negative 2, negative 2, negative 2. So minus 2 here at the end. That means that my y-intercept, if I plug in 0 for x, all the terms until the constant are going to go to 0. So my y-intercept is going to be negative 2. And look at this. What do we have? We have an odd degree. Negative leading coefficient. So that's going to have a right arm down, left arm up. So let's kind of draw that rough sketch. I'm going to touch there. Well, I didn't draw it very well. Let's try that again. Oh, that's terrible. Let's try it. Let's just start. Let's try it again. There's 1/3. I'm going to touch there. There's negative 1. I'm going to cross there. My right arm's going to be down. And my y-intercept is going to be negative 2. Alright, don't worry about that dash right there, okay? So there's my y-intercept. Okay, so that means, I think, that I'm going to kind of come up here and touch it 1/3 and go down there and cross the y at negative 2, then come back up here. Something like that. Now, which graph looks something like that? I think choice C. Ooh, I think choice C looks like the best answer. It's got the left arm, it's got the right arm down. Notice it's kind of confusing because notice that the endpoints here are 2 and negative 2. That means this is 1 and negative 1 right here. So that's a good for 1/3. That's good for negative 1. It touches there, it crosses there. The arms are pointing the right direction. So, and it's crossing the x, it's crossing the y-axis right there. Notice this, that the y-min down here is negative 12, which means these dashes count by 2, so that is negative 2 right there. So that looks like the best answer. Another strategy you could have would be kind of an easy way out, maybe, would be to graph this function in the graphing calculator. Just type it in your graphing calculator just like it's written here. So type in with the parentheses and everything just like it's written into y1. And then when you graph it, make your window be what your multiple choice windows are. So I would make my x min negative 2, my x max 2, my y min negative 12, my y max 12, and see which graph matches your graphing calculator. Alright, now we're looking at polynomial inequalities. Okay, so here's how we can do that. We can solve this. I want to find the zeros, and we can do that in the app or with the graph or perhaps by hand. I'm going to go ahead and solve this in the app. Alright, x cubed minus 6x squared. Polynomial Polyroot finder. Alright, next. 1, -6, -24. 64. Solve. 8, -4, and 2. Okay. 8, -4, and 2. Alright, let me just show you a couple of ways to think about this. One way to think about it is a number line, -4, 2, 8. And you can do some test points, like you can put in like something on each section of this that's divided up by these numbers. You could put in a -5, put a -5 in for x and see if it comes out true. Here, the easiest thing to put in this one would be a 0. Maybe put in for this section, put in a 3, and maybe for this section, put in a 9. So like for example, let's say if I'm putting in a -5. I'm doing -5 cubed minus 6 times -5 squared minus 24 times -5 plus 64 is greater than or equal to 0, and I'm trying to see if that's true. So that's -5 cubed, that's -125. That's going to be -5 squared, that's 25 times -6, that's -150. -24 times 5, that's going to be positive 120 plus 64 greater than or equal to 0. Let's see. That's -275 plus 120 plus 64. Let's see. -275 plus 100 is -175. -175 plus 20, -155 plus 64. That's going to be negative something. That's going to be a negative number. -155 plus 64, -91. I didn't really need to know it was -91, but as long as I knew it was a negative number, I could answer the question. Is greater than or equal to 0. Is that true? It is not true. That means this is not part of the solution. Then you plug in 0 and try it and see if it's part of the solution. See if it comes out true. If it does come out true, then it is part of the solution. 0 will be easy to plug in, so let me do that quickly. 0 cubed minus 6 times 0 squared minus 24 times 0 plus 64 greater than or equal to 64. I'm sorry, greater than or equal to 0. That's 0, that's 0, that's 0. So we get 64 is greater than or equal to 0. Is that true? Yes, that's true. That means that this whole section here, this whole section right here is part of the solution. And I'll just go and tell you, this section is not, this section is not, this section is. So the way I would write my answer then is with an interval. What's the interval? The interval is -4 to 2. And notice since it says greater than or equal to 0, if it just said greater than, that'd be different. But since it says greater than or equal to 0, the -4 and the 2 are included because they are equal to 0 there. If it just said greater than 0 instead of greater than or equal to 0, they would not be included, and I would have used parentheses. So -4 to 2 union 8 to infinity. And the parenthesis always goes on infinity. So this would be my answer. Now let me show you another way to do this that might be kind of sort of think about. So we had our answers. They were 8, -4, and 2. Those were our zeros. Then what you could do is you could just sketch a graph. 1, 2, 3, 4, 5, 6, 7, 8, and 2, and -4. And you just got to remember like what this thing looks like. It's an x cubed, right? Positive leading coefficient, odd degree, right arm points up. These are all multiplicity 1, so odd multiplicity. So it crosses at each one of these. Right arm points up. It crosses there, it crosses there, it crosses there. And then I'm trying to determine where is this graph greater than or equal to 0? In other words, where is the y value above the x-axis? That means above 0 for the y value. That's throughout here and throughout there. which means as far as the x-axis is concerned, it'll be these values and all these values, right? So that tells me the answer. What are these values? Well, it's from -4 to 2, and I'm going to include them because it's greater than or equal to 0, and all these values which go from 8 all the way to infinity. Include the 8 and don't include the infinity. That's another way to do it. You could even use your graphing calculator to kind of help you know what the graph looks like, if you would rather think of it that way instead of graphing it by hand. Moving on to the next question. Alright, for this one, same situation. Alright, again, we need to find the zeros of this first to solve this inequality. You could try to use the app, but let me warn you here, the app is going to give you an irrational decimal, which is fine if it's allowable as an answer in MathXL, but I can tell you that and MathXL wants an exact answer using radicals on this problem. So we can solve this one by factoring. This will factor what two things multiply to get x to the 4th, x squared and x squared. What can multiply to get 175 and add to get -32, -25, and -7. So if I solve those, if I set this one equal to 0, I get x equals plus minus 5. If I set this one equal to 0, I get plus or minus the square root of 7, which is about 2.65. So let's look at that on a graph to help us solve this inequality. I think that makes it visually make more sense. So we're gonna cross, and each one of them, by the way, is multiplicity 1. So cross at each one of them. -5. We cross at negative square root of 7, which is about right here. We cross at the positive square root of 7, which is about right here, and at 5. And we're in x to the 4th with an even degree, positive leading coefficient. That means both arms point up. So something, sorry about that, something like this. Got a little shaky hand sometimes. So something like that. And we want to know, where are we less than or equal to 0? Well, that would be, where are we below the x-axis? That would be right in here and right in here. So as far as the x-axis is concerned, the x values, it would be these values and these values. So how do I express that answer as an interval? It would be, since it's an equal to sign on it, less than or equal to is going to be inclusive. So bracket -5 to the negative square root of 7. Union, that's this right here. That's all that. And then what's this? That's going to be positive square root of 7 to 5. Oh, I should have put a bracket on that too. To 5. And that should be a good answer. Let's type it in just to make sure that is right. Bracket -5, comma. You can hit your square root by going down here, but there's also a keyboard shortcut. You can do the /SQRT, and that does a square root also. 7, so it's the negative square root of 7. Bracket. You can do your union sign down here, or again, there's a keyboard shortcut like that. Bracket. Square root of 7, positive square root of 7 to positive 5. And that should be right. And it is, yes. Moving on. All right, these last couple give us the graph, which is nice because I don't have to do any solving by hand. I can just solve this in the graph. So let's look at the graph. Alright. Let's solve it. We're looking for where this graph is greater than or equal to 0. Where is the greater than or equal to 0? Throughout this region and throughout this region. So as far as the x value is concerned, on the x-axis, that would be this and this. So what would that be as an interval? Looks like -4 to 0. It's got an equal to symbol on it, so I'm going to include bracket. Union. Looks like 4 to infinity. With a bracket on the 4 and parenthesis on the infinity. Alright, let's keep going. Last problem. Again, it gives us the graph, so I don't have to do any algebra to solve this to find the zeros. Just use the graph. That's really a helpful thing. We were looking for this. Where's this less than 0? Where's this less than 0? Okay. Here and here. So for the x-axis, the x values, that would be these and these. How do I express that as an interval? It would looks like -9 to -5, and notice it says less than 0 right here. See that? It says less, not say less than or equal to, but it just says less than. So I'm using parentheses, non-inclusive of those numbers. At those numbers, it's on 0, not less than 0. So parentheses, union 5 to 9. And that finally finishes up that Chapter 3 homework assignment. There's also a second, shorter Chapter 3 homework assignment, and I will tackle that in another video. So good luck doing those problems.